Tasia starts recording now. And Zoom starts recording now.
Recording in progress.
All right. Hey, everybody. It is, let's see, what is it? February 28th, 2022. We are in CSCI 1, Introduction to Programming. And we just got done with our first test. And now we're getting ready to start arrays. So let's just dive into it. I got our run again template up. As always, I'm going to put my name. I'm going to put today's date. And this is module 6. And we'll call it lesson A. So to prompt it, think about how we do Riemann sums in calculus. And we did this earlier. But let's just remind you. When we're doing the area under a curve, so you got the, like, some function here. Some function there. Okay. And you're making up a rectangle. You make up a bunch of rectangles, and you send these rectangles to 0 width. And we could call it, they label them. They had xi in the equation. Remember that? X0, x1, x2, xn plus 1, and it just keeps going until we get up to x of the final rectangle. We have to do stuff where we need lots of variables in C++. We do the same thing. In C++, rather than subscripts, we use arrays. A-R-R-A-Y. And they use the square bracket, as you're about to see. So, if everyone's done writing that, I'll leave back up for a second in case anyone's writing it. Although I'm guessing you guys don't write your lecture notes by hand. If anything, you probably type them up. So let's just take a look at an array. We still got to declare the type. I'm going to call it ARR for my array. This will be my array. And I'm going to put bracket, and I'm going to put the number of rectangles. I'm going to say AR4. And then I can go through and assign them. I can say ARR0 equals 1. I could go with ARR1 equals 4. AR2, come down here and do AR3 real quick. Equals, let's go with 9 and 16. So that's one way of doing it. And this declares an integer array with 4 cells or parts called R. And these start populating them. Okay? So let's come over here and look at a little bit more of what's going on. So we made up this integer array called ARR. And what it's doing is it's pointing to 4 boxes. And in this box, I've declared this one to be 1. Then I did ARR1. So this is ARR0. ARR1 is 4. ARR2 is 9. And ARR3 is 16. And remember, we declared it as ARR bracket 4. Integer array bracket 4. Notice 4, and these are the numbers 0 through 3. So for an array of size n, like let's call it the array b sub n, when we set it up, we'll have 0 to n minus 1 indices or indexes. Indexes, the plural of index is really indices. So that's helpful of knowing. It's worth noting. In fact, there is we can do a nice little for loop. These indices make it great to use for loops or any kind of loop. For int I equals 0, I less than 4, I plus plus. If we just see it out to the screen, we can see out what's in there. Element, that's what these boxes are called over here. They're the elements. Of the array. Element I has value, and then I can say ARRI, end line. And so we can print it out to screen just like that. Nice, easy way to print out arrays. For, while, etc. loops are great for arrays. Fantastic. So let's see what happens when we run that. Element 0 has value 1, element 1 has value 4, and it's feeding out everything that we have. I do not want to run again. What happens if I try to print out element 4? Let me do a end line real quick, and then ARR bracket 4. What happens if I try to access the last, I say last element, but it's not. It's not on the list. 0 to 3 is the only ones we have. If I try to access it, what do I get? I get some weird value. Where's that window? So when I run it out, I'm getting this value right here. What do you guys think that value is?
Some stored value.
Some stored value. What's it from?
Don't know though.
Don't know, right? Yeah. C out of ARR4 yields something crazy. Some stored data from something. So, now even when you delete stuff, deleting files from your computer doesn't really delete them. It just deletes the allocation of the memory. And the best example to look at, let's say, oh, calculus textbook. Our calc textbook has, I want to say 15 chapters. You guys are doing chapters 6 through, I think, 9. So you guys are doing 6 through 9 in Calc 2. Depending on the book. Book dependent. And there's a table of contents. Like chapter 8, chapter 7. Let's see, chapter 7. Pages 420 to 495. That's my table of contents. And then later in the book, I actually have the chapter 7. What delete does, delete is like getting rid of the table of contents. If I delete this, I can still see chapter 6 on the table of contents. I can still see chapter 8 on the table of contents. I can't see chapter 7 on the table of contents, but the book still has chapter 7. There are ways around it. You can format your hard drive. You can like format drive. That gets rid of everything. They have what, CC cleaner or some shit like that. That'll help you clean up old files that aren't used with anything. But you've got data stored there that's being shared out. So you don't want to access this. Don't access outside of an array. So don't do that. There is another way to populate an array. So I could say I can make a new array. Let's call it in, I don't know, my R. And I'm just going to put the brackets, but without a value. Oops, equals. And then I can use curly braces and separate these values by commas. Here I haven't declared how big it is. Let's say there was a lot of them there. I've created a variable or an array an integer array of unknown size. So this is doing it directly. You can do it like that. And the way how can I find the size without counting them? I don't know, it's a little rough. You don't want to do that. A little hard to do. There are commands, but we're not going to go over them yet. So, better off to count them. I've got 1, 2, 3, 4, 5, 6, 7. One way I could do it I could just go up to like 10. This is a bad way of doing it. I could make a counter, start it at 0. And I can do C out my element of my array increment the counter. Oh no, that's the counter's not even going to help here. And then just see when it goes bad. But that's no different than really counting them up. 0, 1, 2, 3. They're numbered. I do have them numbered. Element 6 was the last one. Element 6 was the last one. That's my n minus 1. So, oops. The I showed a 6. So, 7 units. Or 7 elements. So that's a problem with arrays. We need to know the size. What if I wanted to... So I'm going to get rid of this. I don't like that. Oop. I don't want to make sure I delete something off the screen. We don't need that. I'm going to leave that in the notes. I must have the insert key hit. There we go. There's another way I could populate this. I could populate this in a for loop. And I can actually overwrite the values. What is this? What does it look like I'm doing here? What does this array look like?
X squared.
It's x squared, right? So if I did, maybe let's include C math. So we'll do pow I squared. Let's see what we get. Because I got the C outline right after it. I'm off. My array didn't have 0. It went 1, 4, 9, 16 up here. So we can see that we're off. We're off by 1. So that's always something you kind of want to pay attention to. It can't hurt to run a for loop with I equals 0. You should always start with I equals 0. And using I, just check to see if it works. It didn't. So I'm leaving it there so we can still see for those that aren't here. The other way of doing this, we need it to be 1 higher. We can just say I plus 1, right? Does that work? Yep. And I'm going to include some more C outs down here. Ooh. Tired of seeing that. Notice I've got 4 here in 3 different spots. Kind of sucks. So a good way of doing that is to declare what the index is beforehand. Let's call it n. And I can put n here. And it doesn't like it. It's got a little red line underneath it. Why? Expression must have a constant value. Arrays have to have a constant size at run size. Arrays must have a constant size at runtime. Well, we can do that. We learned how to do constant things. We did global constants outside the main. If I want to do a constant inside the main, I just do it here. The only thing that made it global was moving it outside the main. So we can do that here, and it should still work. And now if I want to make that list a little bit bigger, I could, just change n1s. And I don't need to type these out or populate them ahead of time. Oh. What is the shortcut? Control C is common out. Control U is uncommon. Okay. So now when I run it, I can just get it. I can speed it up that way. So you need to have, when you're going to do a variable to declare an array size, you need to declare it to be constant. Okay? I can't express that enough. It's going to glitch when you try to, it's going to say no when you try to do it. Can we do these? Oh, so there are means to do it at runtime. To declare the size by like user prompt. But we use vectors for that, and that's coming later. What happens if I print this array before I populate it? Here's where I populated the array. If I print it out ahead of time, again, we're accessing data that's not in there. This might be the minimum value. I'm going to have to look. It may not be actual data. Let's see. Cout rand max. Is there a rand min? Oh, rand min is going to be 0. Rand goes from 0 to whatever. What's rand max? Is it like the negative version of that? Nope, rand max is really small. I wonder what that is, because they're all the same, if you notice. It's not rand max, but we'll use rand max later for something. So printing it out ahead of time is no bueno. We don't want to do that. I'll get rid of that. Of course, we could have different types of arrays. We could have double array B of size n. We can have Boolean arrays. We'll say size n just to make it easy. We're going to have character arrays. Char, I like it. But we'll look at this more later. At the char one more later. Might get to it today. It might be on Wednesday. Can we pass them to a function? How do I pass an array to a function? We do it like normal. Normal variable. But we have to pass the size also. So let's just make up one called print array. I'll give it a prototype. So there's a couple ways of writing this. I can say int arg bracket, and then I can pass the constant int size. Another way of doing it, and they don't even need to be in that order. I'm going to comment this one out and say, why did it? We'll go back to remote screen when I need it. I'm not going to actually do it because we don't need two arrays. But the array doesn't need to come first. It could come second. We could just say const int where we don't say the name. And when you're doing that for an array, you don't put the bracket after the array name. You just put it after the name of the data type. So that's another way of doing it. Most people send the array first and the size second. It just seems to be the cool thing to do. So that's my prototype. Oops. Let's come down below and write it up. Well, I can actually just flat out steal this shit. Put it right in there. And I'm not going to n, I'm going to size. And I called it arg, not ARR. So I could just now I made the print array. Just copied what I did in the main, put it down there. And now I just call it by passing the array. I don't need to put the brackets. And I pass it the size. And I called size n here. Okay, so print array. Passing to array. I already said that. I already typed it all out up above. Passing an array requires the array and the size. When you pass an array to a function in the main, you don't need the brackets. And I don't have the brackets there, but we'll see that it works. The hell? Why didn't that work? Let's comment those out. Control C. Control C didn't work. It's coming down here. It should be populating in here. And it's called array. Why is this not running? Did I need that done ahead of time? Am I passing it the wrong thing? What's going on here? Let's do it without the function. Wow. This went to size. My program just like broke.
Oh, it's because you're outputting array n. You should output array I.
Hey, hey, hey. You are right. That's it right there. Fuck.
It took
One
me a
letter.
second too.
One letter. Jesus. There we go. Oh, thank God. Thought I was losing my mind. I'm like, what? All of a sudden, programming doesn't work no more. It's just like it broke. Thank you, Adrian. Good catch. So that's how we can do a print array. What happens if we just see out an array directly? Like that. So we'll put a couple end lines in there, and I'll put another end line in there. Fuck it. WTF. What the fuck is that? Let's show you. So let me re-access my computer screen. Ooh. No, I am on Andy's laptop. So let's come back up here and look at our array. Get rid of some of this shit. So when I see out the array, what it's doing is it's sending me the address of the first element. Okay? It's actually, I think it's in hexadecimal. Let's look at it again. Notice it's got letters in it. So it's sending the address. It's in hexadecimal. Oh, I'm off the screen while I'm writing that. So cout is sending the address of the first element. One way we can look at that, let's add something to our print loop. Let's add the address. How can we access the address of an individual item without just pointing to the first one? So let's increase this at memory address. Oops. And the way we do that is we can do the and symbol. So we say and then we say the name of the where we're looking at. Now this is going to give us the hexadecimal answer. It's arg there. Sorry, my bad. Arg. So I'll make a little comment below this. Is the hexadecimal address of the ith element of array arg. Now, I have a hard time reading hexadecimal easily. So if I want to make it look readable to me, I can cast this as an integer. And if I cast that as an integer, int arg bracket I shows us the addy as an integer. And let's just take a look at it and see what happens when we do it. I got negative. How do you have a memory address that's negative? What the fuck? Did you know memory addresses went negative, Adrian? That's mind blowing to me. I always assumed they were positive. Look at me not knowing shit. How big is the memory address? What's going on here? Well, the distance between each one is 4, as I can see right there. 88 to 84, 84 to 80, 80 to 76. These are all 4 wide. The integer array elements take up 4 units of memory. What are these units? They are 4 bytes. And 1 byte equals 8 bits. And so this is effectively 32-bit. So that's how much room an integer thing takes up. That's accessing the memory address there, taking a look at it. So that's how we access memory addresses. We'll do more with that later. It's not so important right now. I just thought I'd introduce what happens when you see out directly. So this printed the memory address of the first element of the array in hexadecimal. And so we showed down below how to access it. Can arrays change, or can functions change arrays? So I said, how do I pass an array to a function? And then I did the thing above it. Let me put this up here. Can functions modify arrays? Will it change something in the main? Will work in a function change the value of an array in the main? Values in an array in the main. Let's check it out. Let's make up a function. I'm going to call it cubic. We did the squares. Let's do the cubic function. Cubic func. And we're going to have to pass it the same thing, the array. Oh, we'll change the order up. I'll do the size first and then the array. And so that's going to be my prototype kind of thing. I need to declare it above. And n is a constant int. And my array is an integer array. Now copy that, end it with a semicolon. And we'll come down here and we'll make it. See if this works. And I don't know. I don't want to reinvent the wheel, so maybe come steal the code and just edit it. So it's arg, and would you do doing power 3? Oh, something else you gotta do is say what it returns. I'm not actually returning anything, so it's a void. I'm like, why is it mad? So I got my void cubic function. It takes in an integer for the size. It takes in the array. And I have those down here. And we're just doing the cubic. And so let's do we'll print the array. Let's do the print array afterwards again. See if it actually modified it. One through 100, and then 1 to 1,000. So functions modify arrays. Some functions can modify arrays. And the reason why is similar to why it printed out the address up above. For the same reason that it printed out the address when we just did cout. What it's doing is it's passing the address. So the function has direct access to those memory blocks. And we call this passing by reference. And we'll go over some more of that later. Any questions so far? Okay. Seeing none, I'll continue. I'm going to add C time because I want to use some random stuff. And we'll include the std library. So let's take a look at like string arrays. We did integer arrays. Let's do a string array. So I'm going to make a string array. Let's call it suits. And I'm going to have 4 suits. But I don't need to say that size because I'm just going to declare what they are right now. They are hearts, diamonds, clubs, and I was going to type and, spades. So these are the suits in the deck of cards. So if I wanted to try to get something out of a random suit, let's come up here and seed the random. And we do sran time let's do a cout, picking a random suit. And I could make a quick integer if I wanted to. And my random equals rand, and we're going to do mod 4, the same as the suit size, which is convenient because remember rand does 1 less than the value, so it does 0 to 3. and I can just see out the random suit. I can say suits and put in my random number. And it's going to pick a random suit. It picked a diamonds. Picked a diamond. Yeah, let's see what else goes on. Oh, I didn't loop anything. So let's put that in the loop. So it's got a club there. I say again, pick a heart, spade, diamond. Oh, I got all four in the first four. That doesn't happen often. Oh wow, doing a run on diamonds. So we can use random, or we can access a random element by just doing that. I don't need to do this right here. I could instead just do that random bit right here. Random mod 4. And it works just as well. Hearts and clubs and hearts and clubs and spades. So it works just the same. We can use random mod n. So for an array of size n, or 0 to n minus 1 elements, we can use rand mod n to access a random element. Let's take a look at, now that I got rand in, let's take a look at, let's do some Dungeons and Dragons. So I'm going to make that die roll thing. I'm going to do a function that returns a die. And we're not going to have an input. So I'm going to make this function, and we're not going to call it die roll. We're going to call it D20 roll. For all you gamers out there, D&D players, you know what the D20 is for. Whoop, whoop. So we will have it return a random mod 20. But we want to do 1 plus it. Okay. So I got a D20 roll here. This should return a random number. We'll put that in our main. I'll comment out this thing right here. So D20. But that's not going to do anything on its own. We have to see out it. Why do you not like that? It's identified right there. Oh, capital R. Sneaky bastard. So I got a 17, and I could roll this, and if I was playing D&D, I could make my own D20. I can make my own dice roller. So let's look at what computing is often used for. Oftentimes, We don't know the probability of events. Know the probability of outcomes for weird events. Weird situations. I'll give you an example that I am working on right now. In fact, you guys are Phil. If you're with him, I think he's in Jared Birch's class. Benjamin Coates and I made a blackjack game in C++ for Friday Night Labs. And that was last semester. This semester, starting this week, we're going to work on, we want to know, depending on our starting hand, and what the dealer's showing, if we should hit, stand, or double. Have you guys seen the movie 21? Or heard about the MIT blackjack team? They came up with a routine for counting cards where they could, when the card had a certain, the decks had a certain card count, like they were face card heavy or face card light, it changed the probabilities in the deck of drawing one of those face cards later on and changed the way you play. So the MIT blackjack team did this. MIT blackjack team, maybe I should not call it the BJ team, the blackjack team, had programmers that did what me and Benjamin were to do. Ran millions and millions and ran millions of random hands to generate the probability using law of large numbers. The law of large numbers says is as n gets larger. I'm going to change color here. As n gets larger, the proportional results in the results approaches the true probability. You can learn more about this if you take stats or have taken stats here. The idea here is to show that oftentimes you don't know what it is. It happens to be for dice rolls. When the dice are fair, we know what this is. So I'm going to come up here into the main and show, like, we'll do something in here. So let's do a counter, die counter, or roll counter. And we'll start it at 0, and I want a maximum number of rolls. We'll say it's just 100 right now. The probability of rolling a 20 on a 20-sided die is 1 over 20, or 0.05. So let's see if we get that here. Let's just do some random, try this out randomly. Let's do 1,000 rolls. So I'll say while roll counter equals 0, or while roll counter does not equal roll max. And maybe I need to make another one for the actual roll. We'll say actual roll equals 1 plus, or die roll, d20 roll. We already made it. Don't need to keep doing it. And then if, nope, I don't want while roll counter equals 0. I need to make another counter. While counter equals 0. If actual roll equals 20, what I want to happen is I want to add 1 to roll count. This will be our track. So this will track our D20, our 20s. And we should probably increment roll counter or counter. And so counter will roll, keep rolling until we have right now 100 rolls. We can find out how many we actually get. Let's just go with 10 rolls. Let's start low. 10 rolls. And then if I want to find the probability, the proportion of rolls that were 20, I got to divide them. So see out the proportion rolls equal to 20 is, we're going to take our roll counter and we're going to divide it by our roll max. And those are both integers, so maybe we should multiply this by 1.0 to convert to a double. So let's just run this. We're running it 10 times. Let's see what proportion we get. It says 0. Should have rolled one by now. Let's just say double. Cast one of these as a double. Let's change that up to like 100 rolls. And give it around. I'm gonna comment out this stuff up here. Let's take a look at it. I still have it showing the die roll. Let's get rid of that. I don't want to see out the die roll. So I'm getting 0.01, 0.04. It's changing depending on what I roll. So maybe let's go larger. Let's go 1,000. 1,000 enough. 0.035. No. So one way, if I start getting really, I want to let's make it so I show the probability. So I'm going to do like a little if statement in here. I'll do it before. Yeah. If counter, that's our roll, mod 100 equals 0. This will make it so every 100th roll will show the probability. Not that. Curly braces. I'm going to put this value in there right now. Current proportion. It won't be roll max anymore. It'll be over counter. Now we can print out every 100 as we're doing it. This should be before that, though. So this will print to screen every 100 rolls. Every mod n rolls, I'm going to say, because we may want to change that. Let's take a look at what happens. So I don't think 100 is enough. Let's go, or 1,000 is enough. Let's go 100,000. Is 100,000 enough? Oh, it's going a lot. We can see what's happening now. As we scroll back up, it's getting around, it's ricocheting, starting to ricochet around 0.05, somewhere in there. So, in fact, it actually equals it there. And you start getting where, even when there's an error, let's go up to the top where we see how far off it is. Like, we're not really close to it yet. 0.496, 0.498, sort of close. But when we go way down the list, still not doing it. We're still only accurate to a few 3 decimal places. So let's make it like a lot. Maybe we'll do less printouts. We'll print out every 10,000. And now we can see it's to 4 decimal places. It's 0.050 and has been for a while. So when it was a low number, it wasn't that accurate. Remember, this is every 10,000. So even this first one's after 10,000 rolls. Eventually, after enough rolls, we stay where we have 0.0500, and the accuracy doesn't leave that. It never goes outside of that 500 range right there. And it's that way for a while. So we can go more and more and more to try to get more and more accurate. But if I didn't know what it was 0.05, I wouldn't know how far to go. So ideally, you want to run that, like when you're trying to figure out proportions or probabilities of something and you don't know what the result already is, you should go until you start seeing very, very little difference between 2 consecutive results. And here, these results are 10,000 apart, but now we're starting to look pretty close. Okay? That's the idea of law of large numbers. And that's not really array-based. I don't know why I felt like covering that right now. But we can do something with arrays, where we're going to use this law of large numbers idea. And let's just start out with something simple. What if I want to make an array where each element holds a point or coordinate x comma y. Well, I would have two values on the first line, two values for the next cell. Let's look at this over here. I do want to continue. So an XY array. Each cell's got to hold the X and the Y. And I want to do a bunch. So this is kind of like an array in here. An array inside an array. Because we're holding more than one value. I could say X, Y, Z to do three-dimensional coordinates. This is a multi-dimensional array. And the way we do it is we do our data type first. We say the thing. I will call, like in this case, I'll call it my points. And then what you want to do is you're going to have rows and columns. Number of rows, number of columns. So if I was making like an XY table, each point would be in its own row. I have two columns here. So maybe we go 100 rows. If I want 100 points, I'll set it up with int my points 100 comma or bracket 2. That's how we can set it up. So I'm going to do that. Let's turn off this D20 counter roll thing for now. But we'll have the D20 down there with it. I'll put this above it. So let's just make a multi-dimensional array. It stores integers in both. If you want to store different stuff in each, you're going to have to do something that we do in CSCI 2. So we're going to keep the same thing in each. And I'm going to call it, I said 100 there, but maybe I'll say num points here. And then I'll say 2. And I'll make up a constant int num points. And we'll just set it equal to 100 for now. So this is going to create an array of, this has 100 rows with 2 values in each, x comma y. So like, let's how could I, well, let's make a table first. Let's see how would I make a table? Let's make a function that makes a table. Do we want to pass anything in? Yeah, let's pass in a multi-dimensional array. I'm going to pass it int arg bracket bracket const int size of points. Shit, it doesn't want to do the multi-dimensional table. I think we got to do something else very different. We can't do functions with it. Let's just do it in the main. And I'll look it up later. So let's see. We're gonna see out. We'll start off with. We gotta do underscore a few times. Let's do slash tab X. And then we'll do 2 more tabs and Y. I don't know how big I got to make these rows. And I want a vertical bar between them. So we'll put a pipe in there. I think maybe it should only be 1 tab. There we go. I don't know, maybe it's 10. That's 6, 7, 8. We'll try 8 wide. One, I didn't count them while I was doing it. 1, 2, 3, 4, 5, 6, 7, 8. And let's just generate the points real quick. Let's do a loop. Or int I equals 0, I less than num points, I plus plus. So what do we got to do? We got to enter a value for x, and then we need to enter a value for y. So let's just use like rand mod 100. So we will make num points, or not, sorry, the array is called my points. We will look at the first cell is x. No, we're doing a row. Row is first. Row is first, and then the first cell is x equals, let's say, 1 plus rand. I forgot, let's do die roll. And did I turn off die roll? Oh, it's capital R. And then we'll do something for the second one. So when you're populating these, there's a couple ways to do this. I'm doing this by setting, oops, brackets, I each time, and then I change this one. Later on, I'll show you how to just do like a looping structure. We can do it in here too. I'm going to do it this way. This is one way of doing it. So here I populate the 0 cell of, this does cell 0 or element 0, which is my x, or row I. And this one right here does element 1, which is my y, for row I. And I could just print out my loop here. I less than num points, I plus plus. I'm trying to get it to look like that. So I'm going to see out. I need to do a tab first, so that goes underneath the x. And then I'm going to do my points, the ith row, cell 0. And then we had the pipe and the tab. And then we're going to do my points I comma 1, which will give me the x or the y values. So multi-dimensional arrays are a little tricky. I probably should have held this off for another day. This is what you learn in hindsight. Let's just see how my table looks. Let's see what happens. Let's not make it 100. Let's make it, that's a lot of points. Let's go with 10 for now. Does my table look good? Not really. So there's a way around that. Let's add another tab after the X. Which means I should add more underlines. 1, 2, 3, 4, 5, 6, 7, 8. And I need to do another tab after the point. Let's see how that looks. I need another space, but it's pretty close. That's not bad. Let's do another space after the tab and let's see how that looks. Oh, hot damn, that's sexy. That's sexy. I like it. So what we've done here, we've populated that array of 10 rows, and we're doing the x value and the y value with each of these. Remember how we calculated pi before? We had a formula that used factorials to do pi before. So let me show you another way to calculate pi. A cool way to calculate pi using law of large numbers. So we know the area of a circle is pi r squared. And if I force the radius to equal 1, the area equals pi. Radius equals 1 is a unit circle. So, like each one of it, for this circle, each one of these is like 1/4 pi, right? This would have pi over 4 area. 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 And this value right here is x equals 1. This value is y equals 1. And we got -1 and y equals -1. So what if I just focused on the first quadrant? Let's focus on this box right here. The area inside there, all the points inside that circle, that quarter circle, well, we know x is less than, or 0 is less than x, less than 1. We know the same thing for y. But we know that edge of that circle is x squared plus y squared equals 1. So if I say it's less than or equal to 1, it actually captures all that region in here. How can I do that in C++? Like, I can pick random points, right? I can generate random points. We just did that. We got our function right here that generates random points. So we can generate random points. Maybe then check to see if they are in the circle. If they are, maybe we can add them up. So like maybe these are like darts. So my pi darts hit inside the circle will make it a counter that starts at 0. And every time I hit, we increment. But adding all those up, even if I divide by the area, which is 1, the area of the whole rectangle is 1, I'm going to get the proportion of hits that are in there. But if I multiply this by 4, that simulates doing the other rectangles. That simulates doing the rest of over here. That simulates this portion. If I multiply by 4. And that should give me the value, right? So whatever proportion of the darts are in here, like I can't just count up how many darts. This is really like the proportion of darts. The proportion of darts that hit in the circle should be around 1/4 pi. So we can try to simulate that. If we want pi, just multiply it by 4. So let's see if we can do that here. So I'm going to comment this out for now. Let's see. So we want more than 10 points. We saw that we need a lot. When we're doing law of large numbers, we need a lot. So we need to make a pi counter. I said pi darts. And let's go from there. So how do I do x squared plus y squared using this? Now this was my x, and that's my y. But I don't want to use D20. I want to do a way to get a number, a random number to get a random number between 0 and 1, which is what we want for the unit circle, right? We can do rand mod 20, or rand divided by rand max. That'll give us a value between 0 and 1. This will give us a value between 0 and 1, and then I need to take those values and square them. So let's just see, int, we'll call it checker. And we're going to say checker equals, I want to square the first one. So pow, comma 2. And I want to square the second one. I need to put the second one in there. So this is my x squared plus my y squared. And now if I want to see if it's in the circle, I gotta do if checker is less than or equal to 1. That would put me inside the unit circle. We will increment pi darts. Okay. Oh, I need a semicolon there. Now, the way we get the proportional, calculating the proportion, darts that hit inside the circle, we got to take the number of our pi darts, and we want to divide by our current number of points, which is I at this point. So this would be checker divided by I. So maybe I'll make it so we'll do like we had that C out every 100 or so before. What did I do with it? Being lazy. Uncomment. We're not doing counter right now. We're just doing I. And now we're looking at the current value of pi is, and we're going to do our checker divided by, I hasn't incremented yet, so we're going to say I plus 1. I increments at the end of the for loop. Maybe I should put that in parentheses. And that's only 1/4 of it, so we need to do 4 times that. Let's just see what happens as we do. That's a lot of darts. Maybe I'll lower it a little bit for now. That's 10,000 darts. Let's check every 100 rolls. Let's see if this works. I fucking did a lot of coding here without checking to see if it was working. That was bad. Something didn't work. Oh, I don't want checker. I want pi darts. That's what I wanted. I just said that right here, and then I didn't put it in. Then I stupidly said checker there. Let's try that. Really? It's 4 the whole way? Is every dart hitting inside of it? Let's try that. Every single dart is less than or equal to that. How is that even strategically possible? That every single dart, did I do this wrong? Unit circle is x squared plus y squared is less than or equal to 1. Maybe I just don't have enough points. Let's go more points. Maybe I just had weird rolls. That doesn't seem likely, though. I think there's something wrong with my code. And I broke some shit. What did I break? Ooh. I'm making an array that's too big. So maybe we gotta change our strategy to do this. I'm just gonna keep these locked in at 1. I guess the dart thing wasn't a great thing to do the array on. Let's see if it works, though. We got 1,000,000 points or some shit like that in there. Yeah, that's 1,000,000 points. Something's wrong. That should be 0. Because there is no 1. Let's try that. It doesn't look like I'm getting anything different. Hmm. Because I know like 0.9 squared plus 0.9 squared. Oops. Is 1.62. There are points in that region that are not. Oh, that still says 1, 1. I didn't change that shit. Oops. Okay, let's try that. Nope, still saying every dart is hitting. What am I doing wrong here, Adrian? So this makes my x. I'm doing rand divided by rand max. It should give me a value between 0 and 1. I know what. Let's just switch it down real quick and let's print out the table that goes with it. So I'll put the table starting up here. And then we got our C out. And we've made it so we're only using row 0. I technically don't need a 2-element array anymore, or a multi-dimensional array anymore. So let's just switch off a multi-dimensional array, which would make this easier for people to follow. Let's just see what they're looking like for 10 of them. Am I getting the values I think I'm getting? Nope, they're all saying 0. And that's because I called it an integer. Let's call this a double. That's the problem right there. Still got a double going on. Oh, I got to cast one of these as a double. Now I'm getting different points. Okay, the table looks like shit, but I'm getting different points. Okay, so that's what was wrong. I was using an integer rather than a double. Let's get rid of our table. And we're doing every 1,000 there, and we got a lot there. So let's just see how pi looks as it's going. You're fucking kidding me. Here I explicitly cast pi darts as a double. Let's just say if I'm on 1, and let's go low. Is it ever changing? No, every dart is still hitting. I'm getting zeros and ones. The fuck? Oh, checker's a double too, or an integer too. Fail. Oh, teacher is sucking today. Sucking big time. There we go. There we go. Now I can get rid of the C out. Now we can make it go a lot more often. Oh my gosh. So this is what happens when you go through code. You guys are used to this by now. The frustration of figuring out what the fuck you're doing wrong. That's it right here. This is the real value of getting frustrated. Still not there, is it? 3.14159. And we'll check every 100,000th toss of a dart. Now we've been in the 3.141 range for a while. Now we're trying to fix that last few decimal places. And we're getting pretty close to there, right? It's ricocheting right around 159. It went below it a couple times. It's going above it, but it's hitting around there. That's a lot of tosses of the dice. Oh, it dropped back down. Why is it going down? We're just having some shitty tosses of the dice. Huh. Oh, this is showing. Yeah, no, it's showing. We're off by a little bit. It's going around 147 right now. Is it going to go back up? Okay, that's a lot of dice tosses. Let's do it less often. Let's add another zero there. Oop. So you can see this doesn't converge to pi very fast. It's very, very, very slow convergence. But it is possible to get it using that area of a circle thing that we had going on. Is it still up? No, they turned it off. And I think we're at 6 o'clock, so maybe I better call it a stop. So multi-dimensional arrays, you don't really have a lot to do with that right now. But you can do them as we showed with the table earlier. We showed making the table. and we can use it for different things. We could also, like I was showing you, oh, I know what I was going to do with the D20 thing. Let me just do it real quick. I can do it pretty quick. I know I can. So I got my darts thing. We'll comment out this for now. I got my rolls here. What I want to do is make it a die tracker. Or die tracker. We'll make it an array that's 20 in size. Nope, I'm going to make it 21 in size. So this will give me 0 to 20. And I'll just ignore the 0 for now. And then as I roll the die, let's comment that out. As I roll the die, I am going to increment die tracker for that roll. So actual roll is giving me a number between 1 and 20. And if I throw that in here, I'm referencing that square right there. And I should be able to go plus plus. And then after it's done, we do not. Let's see. So for int I equals 0, I less than 21, I plus plus. See out the proportion of rolls that were I is, and now we want to do double our die tracker for that value. Divided by roll max. And that should show us the proportion. Maybe we won't go so large. Just do like 100,000 for now. See how this works. It doesn't like something. It doesn't like I. What do you not like here? What? Oh. I put a comma in like a scrub. Really? Oh, I guess I got to implement it or instantiate them all to 0 first. Now it'll add them up. Oh, the testing. Oh, the fun. So these are all close to 0.05. And we knew there was no rule of 0 on a D20. And if we run it again, the values will be slightly different. But if we do it enough, they should all be pretty close to 0.5. I went too big. There it goes. And to 4 decimal places, they're all 0.05. All right, that's it for now. I'll have this posted, and we will do more with arrays on Wednesday, and we can answer any questions with arrays that pop up. If you got any questions, let me know. Otherwise, we are adjourned for the day. All right.
Recording stopped.